for Indo-German Tool Room. We welcome you, sir.
Thank you, Vaibhav, for your introduction. So, should I share my screen?
Thank you, sir.
Yes, sir, you can start sharing the screen.
Okay. Is my screen? Hello.
Yes, sir, it is visible. Yes.
Hello.
Not till now, sir. The screen is not visible.
Is it visible?
No, sir.
Okay. Wait, I think there is a network issue.
So it was visible now, but now you have stopped screen sharing.
Hello.
Yes, sir.
I think the, is
Yes,
it visible?
your screen is now visible.
Okay, so I'm starting my PPT.
Yes.
So already my introduction has been done. Let me introduce myself again. My name is Mayur Inkar, and I have done my BTech from Well Institute of Technology, Bhopal. My branch in my engineering was mechanical engineering, and currently I'm very interested and currently working as an automation engineer in now. So here are some of my past experiences. I have done some internships in Sanjay Auto and Tooltech SPM. So Sanjay Auto was a gear manufacturing company where they are manufacturing the automotive parts, and there I was the lead to just control the Fanuc robotic arm, as you can see in my email, Fanuc robotic arm behind me. And take SPM, I got exposure to the SPM industry, which is a special purpose manufacturing industry in which we will manufacture the entire automatic machine from the scratch as per the demands of the company. So let's dig into the main topic. So, what is industrial automation? So, industrial automation is a control of machinery and process used in various industries by autonomous system through the use of robotics and computer software. This is a very word-to-word definition. For ease it down, you can take it as for an industry to uh, repeat any process again and again rather than using humans. We are using robots. By using robots, we are just automating that process. Indirectly, we are reducing the human work, we are increasing the productivity, the speed, and the everything. So industries implement automation to increase productivity and reduce the cost related to employees, their benefits, and other associate expenses, while increasing precision and flexibility. Industrial automation. So basically, industrial automation contains very huge field. Okay, industrial automation itself is a very huge field. It has so many different parts in it, like SPM, DCS, process automation. So SPM is a special purpose machine manufacturing, and DC is a distributed control system. So in distributed control system, you will control the entire plant or from a single control panel or office. Okay, it's like in you're having different units and stations of your automation. okay, and you are just controlling all of them at one controller and one display from a control room. It is known as the DCS, okay. And process automation is you are just automating the entire process of manufacturing from raw material to the actual. Okay, so to work in robot industry, as all of us know, it needs a huge knowledge, okay, like mechanical, computer science, electronics, electrical, everything. You should know the basics of every engineering, so you can get into the robotics and automation industry. So why is industrial automation important today? So over the years, there has been continued growth in industrial automation industry worldwide. According to the research and survey, the market for industrial automation is expected to reach USD 153.83 billions by 2022. Okay, so this is just an overview, and it is just the expectations of the calculations that this industry is going to grow up to $153.83 billion this year. Okay, so why every company is moving towards the industrial automation is the main advantages of using industrial automation are reduction of the cost, okay, and the reduction of the human labor. So you can use only one single manufacturing, anything. One single engineer is controlling all of that process with high precision. So it is reducing your labor cost, it is reducing your machining cost, and it is reducing your time also. Okay, it will increase your productivity as the manufacturing rate is increasing, production rate is increasing. You will make manufacture many products in the small cycle times. Okay, harmonization of process or products. The industrial world is facing many technological changes that have increased the urgent need for high quality products and services that can only be delivered like all of us know this, the mobile industry, robotic industry are growing very fast. For every 2 months a new technology is coming into the market. So keep up with to keep up with that market and keep up with that upcoming technology, we have to we have to just dig into the R&D section every industry. And after R&D, we have to do the batch production so that we can fulfill that demand into the entire world. So to do that batch production and to fulfill that demand, industrial automation is needed. Okay, so let's take an example of Coca-Cola. All of you know the Coca-Cola factory, a drink we will have. Okay, so this is how the Coca-Cola plant looks from the inside. Okay, you can see there are so many conveyors over the bottles are going, there are some machines behind and control panels. Okay, so this is a totally automated plant, and this type of automation plants are known as process automation and bottle filling plants. As I explained, process means the form is scratch and making a free deliverable product. Like you have an empty bottle, then you are moving and you are just filling that bottle with Coke, then you are labeling it there, you are putting a cap over it, and at the end you are just packing an entire batch and delivering it. This entire process is being automated. This is known as the process automation. So for Coca-Cola, more than 1.9 billion servings of Coca-Cola drinks are enjoyed in more than 200 countries each day. Just imagine 1.9 billion servings each day. So Coca-Cola has to complete this demand of there in the market. Okay, if they don't manage to complete this demand, their market is going to be decreased and they are going to fall in the market. Okay, so to keep up with this, they are accepting the process automation process. So as a pre-image, Coca-Cola plant bottles are moving from conveyor, getting filled automatically through the nozzles, and the entire process is automated. Each and every bottle is getting filled up to a certain limit. Okay, it is not overfilling and it is not filled half. It is filling to a certain limit in a speed and in a perfect time of process. It is getting labeled, it is getting packed, and it is delivered. Okay, all of this process with the help of some electrical components, hydraulic and pneumatic cylinders, some industrial components like PLC controllers, etc. This entire process is a one-time installation system. So the best part about the industrial automation, it is the one-time installation process. By meaning of one-time installation process means you have to just manufacture the entire thing or entire machine. You have to program it and you have to just go into the industry and you have to install it. Once you have installed it, there will be no problem into the machine. Okay, the process will repeat and repeat for years. You just have to take care of the maintenance time to time. Okay, and the best thing about this is you need only some people of engineers to supervise this process to the maintenance you require. Okay, so what do you think, without automation, how Coca-Cola will maintain this quality and fulfill the market demand? Okay, with without process automation, how much labor they will need, and can a human worker repeat a process with the same quality each and every time, like filling the bottle to up to an extent, packing it, tightening the seal, then carbonating it? This all process a human can do repeatedly with same precision. So it is nearly impossible for a human to make this much of a batch production repeatedly with some same quality, same precision, and less cycle time. Okay, so that's why we need industrial automation. So let's dig into the main branch in which I'm right now working, and I'm currently very interested and enthusiastic about this, which is SPM. SPM stands for Special Production Manufacturing, and it is a type of automation. So as the name implies, it is not a standard machine you will see in the market, like CNC milling, or any hobbing machine, or anything a standard machine you will see in the market. Okay, SPM means like, if a company comes to you and they tells you that they want to automate a process, and for that automating the process they want to manufacture a machine which is totally automated, only one worker can handle it. So at that time you will manufacture a machine which is specially for that purpose which is the company wants. Okay, so that kind of machine is special purpose machine. Okay, so this is not a covered in standard production system. The front should be designed and shown according to the specific needs of customers. Those are called bespoke machines. Okay, and all the manufacturing program, there is need of long-term product quality improvement, reduction, rejection, and increasing individual production. Okay, this stressful condition in the global economy. So to answer all of these questions, SPM is the solution. Okay, so how does a SPM machine manufacture? So what is the process to manufacture a SPM machine? Okay, so first of all, we will get into the CAD modeling. CAD modeling is nothing but designing of the machine over your computers with some softwares like SolidWorks, AutoCAD, Mayur. So these are the softwares. CAD stands for computer design. Over these softwares, you can make a 3D model of your machine, and you can just look into it how it will look. You can do the assemblies over in that software, so that you will get a perfect measurement and the product size and all. Okay, after the completion of the CAD modeling and designing, you will approve the design, you will send it to the manufacturing to the machine shop. Okay, into the machine shop, the worker or the supervisor will look over the drawing, and they will make the parts needed for that drawing according to the dimensions given and the limitations. So there is different kind of machining process like grinding, CNC. These are the machining process. Okay, after the machining processes, there are some surface treatment. Surface treatments are the we will do over to protect it for the environment, like it should not get a rust and all. So first we will do the surface treatment. Surface treatment also has two types. One is only coat it with another layer so that it will not get rust, and one is hardening, surface hardening. Okay, in surface hardening you will increase the hardening of the material so it will not break. Okay, so to do hardening there are so many different processes like quenching and all in the industry available. Okay, so after once you manufacture the product, the most crucial thing is inspection and quality control. Okay, you can't take a part and you do not inspect it, you do not cross check its the drawing, and you go and assemble it. Even a small micron of a tolerance increase and decrease in the assembly can just fail the entire structure of your machine. It can create vibrations, it can create failures. Entire machine can go fail just due to some microns. Okay, micron means like it is the 10th part of a mm. Okay, so after that, the quality control and inspection, you will go into the control panel designing and assembly. Okay, so in control panel designing and assembly, as we are making an automatic machine, they are obviously it is going to have some electrical components. Okay, so all of the electrical components of each machine, it is going to be installed in a control panel. Okay, the control panel is nothing but a metal box in which all of your electrical components like MCB, servo drives, your protection devices, your controller, your transducer, transformer, everything, each and every electrical device is stored in a control panel. Okay, and in that control panel you will do the wiring of that control panel. So before doing the wiring of that control panel, we will also make a ECAD file, like electrical designing file of that control panel over a ECAD software. So there are so many ECAD software present in the market, like E-Plan, Auto Electrical. Some of my friends must know about this. So you will design the control panel and assemble everything. Okay, so this is the main controller of your machine, which is a PLC, stands for programmable logic controllers. Okay, it is a small computer in your machine which is going to control your entire machine and entire process in it. Okay, so it has CPU, some digital inputs and some digital outputs. Okay, through digital inputs, this PLC takes signals from the sensors and the electrical components which are present into the machine, and then it will take that inputs, and it will give the outputs as you program to the cylinders, drilling, grindings, whatever you have done into the machine. Okay, so this PLC has different kind of languages to program. The languages mainly used in the industry are most three languages, which is ladder logic, statement logic, and functional block diagram. So this is how a PLC look. You can see in the image, this is a Siemens PLC. Siemens is a company which manufactures this PLC. Okay, so once the programming of this PLC is done, you just have to test the program, and after testing the program, your machine is okay, your machine is done manufactured. So what is a PLC? A programmable logic control is a type of tiny computer that can receive data through the inputs and send operating instructions through its outputs. Fundamentally, a PLC's job is to control a system functions using the internal logic program into it. You will program it and you will just upload the program into the PLC. Once it is stored, it is not like it cannot upgrade it on its own until you do it. So once the program is loaded, the PLC will follow the entire process as you program. So here are some leading manufacturers of the PLC. Uh, there are some Siemens, Rockwell, Mitsubishi, Schneider, ABB, Honeywell, Omron, Hitachi. So these all are the industries which manufactures the PLCs. Among these, Siemens and ABB and Rockwell, these are the three mostly used PLCs in the industry. So in this lecture, I will give you a glimpse of a Siemens PLC. So this is an example of Siemens PLC S7 300. S7 300 is the model of this PLC, and Siemens is the manufacturer. Okay, so Sematic S7 300 is a universal controller, saves on installation space and features a modular design. Modular design, you can see it's a compact computer CPU. Okay, it is not as big as our laptops and computer. It is compact. It is around small box, about 10 centimeter to 10 centimeter box. Okay, so in this PLC, like you can use 16 to 24 volt DC input and output source. So the main part about this PLC, this works on 24 volt. Okay, to work with this PLC, you have to give a voltage about 24 volts, so can it work. Okay, and it gives outputs in a signal. These signals are of two types. It is going to give output in a voltage type of signal or ampere type of signal. So here you can see it. This PLC is going to give 0.5 ampere as output. Okay, so to program this Siemens PLC, Siemens has its own software. Okay, and that software is known as TIA portal. Okay, so what is TIA portal? So TIA stands for Totally Integrated Automation Portal. Okay, it gives you unrestricted access to the complete range of digitalized automation services, from digital planning to integrate engineering and transparent operations. Okay, so Siemens has built so many different kind of PLCs. So to program all of those PLCs, you can just go into the totally integrated automation software and you can program all of them. And not only that, it is used to program HMI. HMI is nothing but human machine interface. It is a display over a machine from which you can control the machine manually also. Okay, so you can also program a HMI through this software. You can also make a SCADA software, a SCADA screen. SCADA screen is nothing but a visualization animation of your process of your machine. What it is going to do. Like you are going to pick one object one place and you are going to drop it another place. You will make simple animation of that, you upload it into the HMI, and that animation is known as the SCADA. Okay, so this is how a PLC program looks like in a TIA portal. Okay, so as you can see, there are some vertical lines on the left side, and there are some curves on the right side. So these vertical lines will induct, or what can I say, just it shows your inputs. Okay, and the curves and the coils you're seeing and on the right side are the outputs. Okay, like these are the outputs and these are the inputs. Okay, so this is a NO input. NO means normally open input, and this is a NC input. Okay, means a normally closed input. Okay, so NO input means this input shows that right now PLC is not getting any signal. Okay, once you will get a signal now, this NO will convert into the NC like this. NO stands for normally open circuit. Okay, so this NO switch convert to NC, normally closed switch, and it will flow the current through this, and this output will get the signal from the PLC and the voltage from the PLC, and it will operate like this. This is a ladder program. This is the ladder logic program you are seeing on the screen, watching on the screen. Okay, so this is how a ladder logic looks, and this is how PLC program looks. Now this is a control panel wire diagram. This is how you will design your ECAD file of a control panel. Like you can see, these are the wire notations, and this is the phase wire, neutral wire, ground wire. You will give these notations in the program, sorry, in the file. And this is the electrical device, how it is connected through the MCB in between. Now through MCB, these three connections are going away, and as you can see, there is a numbering to this wire, which is W1, W2, W3. Okay, so this wire numbering shows that on the next page of this drawing there will be another your electrical device. Okay, and that electrical device may be getting connection through these wires. Okay, so these three naming of these wires will be available on each and every wire on the sheet, okay, of your drawing. So by watching that wire and wire number, you can understand that from where this connection is coming and how your component is getting the electricity or the voltage they needs to work. Okay, so this is all about the special purpose manufacturing and all. So thank you for hearing me out. So if you have some questions, you can ask. I hope I didn't go very fast and all. Hello.
So can I start with my question?
Yeah. So do you have any questions so that
Yes. So thank you,
regarding
sir,
this?
for keeping such a great session. Sir, I had a question regarding the conveyor belt, which is used in industrial automation.
Okay.
So how can the frictional
What? Can you
challenges?
repeat?
Sir, I had a doubt in like the conveyor belt, which
Okay.
is used
So
in. Yes, sir.
conveyor
Go
belt.
ahead. Yes, sir.
Okay, so conveyor belts are of different types. Okay, there is belt chain mechanism, or a roller conveyor. Okay, so it depends upon your application, what kind of a thing you want to move on a roller or a conveyor belt. Okay, so on a conveyor belt, if you are moving a very delicate system, okay, so you have to move it with a rubber belt. Okay, so that rubber belt has a great friction, it will hold your component. Okay, and if you are having a batch of a very huge product and you want to move it from one surface to the other surface, then you can go with the rollers. Okay, so rollers are basically metal cylinders, including the bearings in it. Okay, so it can handle the pressure and the weight of the object, and they can carry it from one place to the another place very easily.
Yes, sir. Sir, how do we solve the frictional
Hello.
challenges in them?
Frictional challenges like in the motion or in the object and build.
Yes, in the motion, like moving the objects in one line like that.
So yeah, so to reduce the friction, you can go for the different mechanisms used today. Like one of the famous mechanism is going on right now is the chain and pulley mechanism. Okay, so you will just have a there are different materials also available for the conveyor belt, as you can see. Some silicon materials are also available which are having so much less friction over them. And if you go for a rubber, and it will have a high friction. So two things are the most important while you are doing with the friction. First one is the material of your build, because every material has a surface friction property. Okay, you have to just understand it and you just to study about it. And second is the motor and the your mechanism, how you're rotating that belt. Okay, so if your belt is rotating very slowly, okay, and if you want to get your product suddenly from one place to the another place, so the moving mechanism is the most important thing here. Okay, for the friction part, mostly thing you can do is go and study about the conveyor materials, built materials, what kind of friction you want. You want a great friction or you want a less friction. According to that, you have to study the material properties, and over that material properties you have to just select the bit. Okay, like for conveyors in industry and conveyors in robotics, robotic wheels. Okay, these are two types of different conveyors. Okay, for a robotic wheel or a or automobile, there are also some conveyor belts. Okay, conveyor belts, they are manufactured differently. Okay, they have some threaded of a metal in it. Okay, over the entire conveyor material is placed and sandwiched it. Okay, so they are having a high strength in it. Over if you go into industry where they are using the conveyors in the plant, now they are a little bit of different materials, like they are low weight. Okay, they are very smooth and they are very flexible, they can move very easily. And again, there are two types, as I explained, one is roller and one is rubber belt. So they go for according to the application.
Yes, sir. Sir,
Hello.
just one more question I have. Sir, all these machines which you showed, the PLC,
What?
sir, they have a, sir, like these machines which you showed,
Huh?
sir, they have a like a printed circuit board in them, right,
Mm-hmm.
sir? Like, sir, like we know that now there's a huge silicon
Yeah,
chip
yeah,
shortage. So how are we dealing with the shortage of chips
yeah.
in industries?
Okay, so for yeah, so for I know all of our students, while making any project, you will using Arduino or Raspberry Pi as of your controllers. Okay, so these controllers are very basic controllers and they can't handle high voltage input and output. If you give a very high voltage to Arduino, it will just go and burn. Okay, so to deal this problem in industries, they have built this PLC. Okay, so this PLC also is having an integrated circuit board in it. Okay, but this PLC is just a single CPU. Okay, so to control different processes, you don't have to control and you don't have to have built different circuit boards. Okay, you just have to you just have a single component, a box, a PLC in which only a single motherboard is available, which is controlling the entire machine, and even an entire panel or even an entire plant it can control. A single PLC, but it is different with the Arduinos and other controllers. To each and every process and to each and every automation, you will have to design a circuit board, you have to design a component over it, and you have to manufacture it. Okay, so you have to do this repeat and repeat for each and every process. But in PLC, why industries are accepting PLCs to build a machine? Because a single PLC is handling so much work. So what do you think? Which is convenient? Having 100 circuit boards to control a single machine, or having only single computer and a single motherboard to control an entire plant? So that's why industries are moving towards, industries are using PLC and it is having a single computer. So I don't think so it is just a shortage of PLCs in the industry. You can get PLCs anywhere.
Okay, thank you, sir.
Yeah.
Sir, yeah, I had a doubt, sir. Sir, how are they achieving autonomously
Yeah.
all this systems? Like, what all softwares are being used to achieve autonomous in this conveyor belts and all? It's least human interaction.
So okay, so as I explained, for Siemens PLC, Siemens has its own software, which is named as TIA Portal. Okay, totally integrated automation portal. Okay, so for, as you know, for Arduino programming, we are using the languages for, like C and C++. Okay, we are programming them into our laptops. We are coding them into the C or C++. We are just downloading that program into the Arduino boards and we are running our robots. Like that only in industries also, each manufacturer of the PLC like Siemens, Mitsubishi, ABB, they all have their own PLC and their own softwares. Okay, it is not it is means like it is not necessary you should learn each and every software of each and every industry. You just have to learn the basics of logical control. How does a PLC getting programmed? How does the logic controller is getting worked? Okay, you have to just understand that logic. Once you get that logic, then all companies and their softwares are having different interfaces only, UI interfaces. Okay, and logic behind it also. So once you learn the programming of PLC, you don't have to go and learn each and every software in the open market. Okay, so first thing is to PLC, you have to pick one company and you have to pick the software of that company and that PLC, and you have to learn how to control and how to program that PLC. Once you get a master's, you can go and control and program each and every PLC in this world over their softwares. You will take just only 1 week or some days to get hold on a UI, how it is working and where are the all functions available. So if you are from a mechanical background, any one of you, you know that SolidWorks and Solid Edge are these two different CAD softwares. Okay, you can design a 3D model over both softwares. Okay, there is nothing in it. Just the difference is they are having some different UI interfaces. That's it.
Yes, sir. Sir, and one more doubt I had, sir. Why do we prefer Siemens over other like Rockwell and ABB and Mitsubishi? Is there any specific reason why we are using Siemens over there?
Actually, you're not audible clearly. Can you repeat the question?
Hello, am I audible right now?
Yeah.
Sir, my question is why is Siemens being used mostly when we have Rockwell and other also Mitsubishi,
Oh,
ABB also?
yeah, like so. Siemens is a very leading company in the electrical components. So Siemens is a very old company and MNC. So it is in each and every section of a electrical automation sector you can imagine, like HMIs, controllers, PLCs, electrical components. It's not like Siemens is the most crucial and the most fundamental company in this field. It's just people have trust on the quality of the Siemens which okay, Mitsubishi, ABB, Rockwell, they are also having a very good quality of the PLCs. Okay, but it's just the Siemens managed to get this trust of the users, so that the companies are moving towards the Siemens PLC. And you can say that Siemens is having all of the components. Okay, like if you are having a machine, in that machine you are going to need a component, going to need electrical components, you are going to need PLC, you are going to need HMI. Okay, so the most good advantage about Siemens is manufacturing all of the components and they are industrial standard components. Okay, you can go into the world anywhere. You can same product of the Siemens in the entire world. Okay, so once you build a machine, and another thing about Siemens is their all components are just integrated with each other. Okay, so work with the HMI through a PLC of Siemens, you just have to integrate them into the TIA Portal software, which is a 2-minute process. Okay, but in other companies, if you are using a PLC of a different company and if you are using a HMI of a different company, then you have to work on a different software to program that HMI, and you have to work on a different software to program that PLC of that particular company, and then you have to integrate them. After integrating them, you are going to have a control panel over which you are going to control the machine to human machine interface HMI, and the PLC will control the entire process. But in Siemens, HMI and PLC both are made by Siemens, so you just have to integrate them into a software which is TIA Portal. So because of all of these advantages and have made in the market, Siemens is quite quietly used very much in the industry.
Sir, clear. Thank you, sir.
So I had one question. Initially, you said like it's very well known that the initial setup cost for any automation is it's very high. Do you think we can bring the cost down with like the recent industry 4.0, web 3.0? Do you think we can bring the
Sorry,
cost
you
down?
are also not audible. There is there is so much noise in your background. Can you speak again?
Is it better now?
Hello. Please, can you repeat your question?
Am I audible now, sir?
Yeah, yeah.
Yeah, so you said that the initial setup cost for any automation, industrial automation is very high. Do you think with the recent advancement, industry
Hmm.
4.0 or web 3.0, we can bring the cost down so that we can see it in our
Yeah.
everyday, say, agriculture or not just in industries?
Okay, so in industries 4.1 and 3.0, as I explained, there is a huge market demand for everything, and companies have to keep up with that market demand. Okay, and this human labor, there is nothing wrong to get too much human labor in a company, but company don't want to deal with the quality of their products. Okay, company is not against the human labors and all. Company is willing to hire people who work in their company so that their company can grow and they can provide as much as jobs they can, but company don't want, at the same time company don't want to deal with their quality of the products. So that's why they are moving towards the industry 4.0 and they are accepting this automation so that they can make the batches at a time with the same quality every time, and they can fulfill the market demand.
Thank you, sir.
Okay.
Sir, and sometimes when there is a, as you mentioned, that there should be a lot of precision while you are dealing with, in the case of Coca-Cola, when the factory is
Yeah.
fully automated. So if some incident happen and maybe the bottles are not aligned properly, so in that case, how will the machine deal with it? Will
Hmm.
it require human intervention, or it has
Okay,
a feedback
so
mechanism?
yeah. So as I said, even though if are making the entire plant automated, there will be needing some humans there to watch over it. Those we are called supervisors. And if a company and a machine faces any problem, there should be an engineer, which is a maintenance engineer. Okay. So as you asked, if a machine has a failure and it is not labeling the bottles or filling bottles correctly, so the programmer every time will programming the PLC na, they will develop some alarms in that machine. Okay, like if a process is getting wrong, they will create a alarm in it and they will program it. Okay, so that if a bottle is getting overfilled, okay, like if you to explain this filling of a bottle, there are three sensors basically. One is at the bottom, which will sense, okay, bottle is present here, and he will give a out input to the PLC. Now bottle is here. Now PLC will get an input, okay, bottle is here, and PLC will give a output to the nozzle. Now you have to open because bottle is present. Okay, at that time the nozzle will open and the soda and the drink will be getting poured into the bottle, and bottle will get starts to get filled. On the top of the bottle there will be another sensor which will indicate that the bottle is getting filled, and up to a certain level when the bottle gets filled, this sensor will give a output and to the PLC, and PLC will take an input from that sensor that, okay, this sensor is on means the bottle is filled up to a certain level. So the PLC now will get an input from that sensor and get a give a output to that nozzle. Okay, now you have to stop because the bottle is filled. At that same time, once the bottle is filled, PLC is going to give simultaneous output and a signal to a conveyor belt that you have to start and you have to move forward because the bottle is filled and empty bottle is coming from the back. Okay, but in case overflow or overfilling of bottle happens, there is a third sensor present in the machine. Okay, that third sensor is just collecting the data if is liquid getting overflow or what. Once the sensor gets that detection, it will go and switch the entire process for now. Okay, and PLC, in that PLC you can design different processes in different networks so that it will not harm the entire process. Like if in the PLC if the only filling mechanism is not working properly, so you can hold the filling mechanism and you can just what can I say, keep moving the packing mechanism. Okay, PLC can handle both things. So for each and every error, the programmer has to build an alarm in it so that PLC can get that alarm. PLC can just understand what happened, because for machine to take a inputs and to sense anything around around them, they have to be installed with some sensors around them. For every sensing mechanism, there should be a particular sensor in the machine, that you will get a total data for your surrounding, what's happening into that, and with that input, your programmer, your programmable controller logic will just give outputs to the machines, and it will work like that.
Okay, so yes, got it.
Yeah. Anyone else?
Yes, sir. So just I am quite
If you have any
curious.
question, you can just go and
Yes, sir.
what
I don't think, sir, anyone has any more questions. Uh, it was a very nice and informative session, sir, and everyone got to learn a lot. Thank you for giving your time, sir, and we really enjoyed it. Everyone has, I think, taken a lot from here and would definitely work on this field. Thank you, sir.
yeah. Okay, so thank you for having me, and thank you, Mr. Vishesh Goyal, for inviting me today. I hope I contributed to increase your knowledge a little bit also. And keep working, keep studying, keep hard working. Thank you.
Thank you, sir.